Exponent rule. Need help with those? Come to the right spot. Let's look at prerequisite station number 3. Let's switch it over. Looking at a couple, the main idea here, if you are adding things with the same base, or multiplying things with the same base, you add their exponent. If you are dividing, you subtract their exponent. Let's look at C, D, and E. Through C, start with inside these parentheses. I have k to the 0 power, and anything to the 0 power, it's simply 1. So this just becomes 1 times m. 1 times m is m, and m squared is m squared. Notice the m is being squared, not the negative 4 in this case. So I have negative 4 m squared times k cubed times m. Okay? From there, I'm kind of going to do the multiply in any order I want sort of thing. Like I choose to multiply these two together first because this is all multiplication. I'm allowed to do this. M squared times m to the first is m to the third. The negative 4 is my coefficient, and k cubed is my other variable. So negative 4 m cubed k cubed, that's all we got right there. About letter D. Letter D is saying everything inside these parentheses is being squared. Notice over here the negative 4 was not. That's why it just stayed negative 4. But this time, everything in here needs to get squared, including the 9. So 9 squared is 81. D to the negative third squared is d to the negative 6, multiplying. And if k to the fourth squared is k to the 8. On bottom I have 3. D to the negative 8 times k. Now we're going to combine like term type of thing that we're doing here. We multiplied our m's over here and added their exponents. On this one, we're dividing these two things together, so we should be subtracting their exponents. K to the 8th divided by k to the first is k to the 7th. 81 divided by 3 is 27. And negative 6 minus, right, we're dividing, so I'm going to do minus negative 6 minus a negative 8 is just 2. So we get 27 t to the second is 7. Okay. Let's look at this one. This one has a 2 to the first in the denominator. That's no good for me. If I'm trying to write this expression so it only has a single base of 2, I need the base of 2 to be in the numerator for all of them. So I'm going to move this whole expression, this whole thing up to the numerator. When I do that, the exponent changes on. So I get 2 to the negative first there. I get 2 to the negative second there. And I get 2 cubed being squared there. Pretty tricky little thing there. I changed 8. I changed the base on 8. I made 8 2 to the third power, so it would have a base of 2, which is what we're looking at. 2 to the third squared would be 2 to the third times another 2 to the third. I'm going to multiply those. That is just 2 to the 6th. So finally then, I'm multiplying all these things together. I'm only changing their exponents. Like I'm not changing the 2, I'm changing how many there are. So that's just going to be 2 to the, add all these together, third power, and 2 to the third power is 8, but that's not what it says there. Write the expression with a single base of 2 to the third. Awesome. Try the next one. Moving on.